welcome. I guess most of you went to the Docker guy, even though I posted this picture on Twitter telling you to come here. Anyway, I'm really happy that you decided to show up. I'm Alexander. I'm at the developer conference, and I'm actually going to show you some source code. Just a few words about my talk. It's actually designed as something that you would bring with you home. So I usually don't do this, but there will be a lot of PowerPoint slides, just sort of to get some kind of flow and some kind of build some understanding into the material. I want that material to be able to stand on its own once you get home and review and browse it. So I hope you will learn something about code today. So the topic of my talk today will be cars. There's going to be happy people and fast food. It's going to be some sort of security, and there's going to be code. Does it sound reasonable? Is that somewhere along the line with your expectations? Good. Okay, so just this mandatory slides. Who am I? Okay, I'm a developer. I do some training. I do mentor. Here is Ryan. So I do have plus in Ryan's notebook for mentoring. I'm writing a book. I'm 2 days away from finishing a book. It's on developer testing, and that's actually my big passion. My big passion is bringing together the kind of quality work a developer would do to actually increase the quality of their work with the kind of work a tester would do. And what I've seen is that these two disciplines have diverged. There's tons of testing blogs, there's tester certifications, there's tester tools that sort of never make it to the developer's toolbox, for good reasons, one might argue. But I'm really trying my best in any way I can to sort of fill that gap between development and testing. I really don't want them to be separate professions. So this will be sort of one way of doing this in this talk. I would probably be offended by all us thinking about Scrum Masters, because that's what I am. I'm also a coach in training, so I've realized that the best way of sort of bridging the gap between development and testing is actually by sort of looking at the whole development process and not really fighting with the source code. So that's me. Now we're going to meet a completely different person. We're going to meet Tim. Tim is an elderly gentleman who he runs a company, an insurance company, that happens to be, I'd say, 10 years behind. He runs a car insurance company, and he just has this brilliant idea that he wants to actually publish the sort of quotes online for car insurance premiums. Now, I actually don't know too much about car insurance premiums, but I know that they rely on a bunch of factors, like how old is your car, where do you live, are you male or are you female, what's your driving and accident statistics, and a bunch of factors. We're going to simplify this, since we're going to turn this into a coding exercise quite fast. So now Tim wants a minimum marketable feature, like a minimum viable product, and he decides that his premiums are only based on age and on gender, because we know, at least in Sweden, that female drivers are better drivers in terms of accident statistics. So from this table, it's quite obvious that female drivers should pay a lower premium for car insurance premium. Okay, so we're just going to dive into code immediately. And I sort of hope that the majority of you are doing test-driven development, and that your spinal reaction would sort of be along these lines. Sort of, kind of. Now, I've simplified this to just be a unit test, but this is sort of what you would do. You would pick the first value from this, and you would write a test to confirm that. Okay, we're developing Tim's new premium rule engine, and we have a first test case, right? Right. Okay. Now, it happens to be tabular data, so our next test case isn't going to be awfully exciting. As you see, it's only some, and there's actually, there's just some values flipping. We're looking at age 18, we're looking at age 23, and it's not a really exciting test. And this is actually one of the things that stop developers from writing tests, except for crappy architectures that don't support testability, legacy issues, 10 layers of EGB crap and anti-patterns. But somewhere, this is a contributing factor. And this is something a tester would care about, because those testers who usually go for the ISTQB exams, they will immediately see, aha, there's an equivalence partition here, there's boundary values here. This would sort of be important at the fundamental level. And for some reason, at least my experience is that this isn't important for developers. This fundamental level of checking isn't important for God only knows why, for what reason. So anyway, we would probably stop writing these tests. We would give up after the second test. And there is a solution to this, which is sort of built into all testing frameworks by now. And when I say all testing frameworks, I refer to JUnit, TestNG, and NUnit, because I sort of do cheat and work on C# projects as well. And it's called parameterized tests. But before showing them, let's just see what kind of structures we see in these simple tests. We can see that naming will sort of get messed up here, right? Because there's no good way, at least in my mind, to name tests that look like this. There are, to my knowledge, there are 3 naming schemes for unit for testing, and regardless of what scheme you would pick, it would just come out silly. Because my favorite naming scheme usually involves, it's a structure where you say, this module, this unit of work, is operating under those conditions, and I'm expecting that outcome. In this case, it would just be stupid. So that's why my test name is sort of, that's why I deliberately sort of chose a poor test name. Obviously, it's going to look very repetitive, right? We had 2 values covered in this table, which was a huge simplification from a read premium rule engine. Right? So the test will look very repetitive, and they're going to get boring to write. And you're not going to convince your project manager, you're not going to convince your colleagues, you're not even going to convince yourselves to write such tests. They will kill your soul. So as I said, there is a cure to this, but how many tests would we actually need to actually cover this? And I've put up this graph, this chart, of just these business rules, and we see there's 6 bars, there's males and females, there's ages, and do you have any sort of theories, guesses? How many test cases would we need? Or let's turn it this way, how would we think when designing tests for something like this? How would we go about this? Do we have any theories? Or am I in Sweden and nobody is going to raise a hand? That's okay, I'm Swedish too, so I don't know nobody's going to raise a hand. So a tester would approach something like this by at least dividing this into equivalence partitions. Just a quick check, does everybody know what an equivalence partition is? That's inconclusive. I don't know whether that was a yes or no. An equivalence partition is actually, we can go back to math and really have a heavy background for it, but in common speak, it's a set of values that are sort of the same from the perspective of a test. So in that case, 18 to 23, it doesn't matter if you put 18, 19, 20, 21, 22, 23, they're all in the same equivalence class, equivalence partition in this interval. And they're of course dependent on the test, right? So obviously, just by looking at this, we see that we've got at least 6 equivalence partitions. And actually we've got even more, because we've got the ones with incorrect values. People that are underaged, maybe there will be some parent doing some fraud registering their kids for the car insurance, and people that are way older, like say purely invalid numbers, like 150 years old. So that could be one or two partitions depending sort of on how anal you are as a tester. So we've got all of those, and between the partitions we have what we're calling boundary values. In developer speak, they're often called edge cases. It's the cases that are sort of between stuff which are interesting. So we do have edge cases around 18, for example, and 17, that's edge cases, right? 24, 23, and all of these. So that sort of gives us a lot of things to test, even for a simple table like this. And you might want to test this, you might not want to test this, but in an environment where this sort of matters, when there's money involved, where there may be lives involved, you do obviously want to test this. So, and you're not gonna do this by writing unit tests, because a unit test relies on examples. So, oh great, it's readable to you. So what you will do, this is the first snippet of source code, and by the way, I apologize for not bringing my clicker. I didn't find it, we've just moved, so I haven't unpacked everything. So what you will do, and this will look similar in all testing frameworks, major testing frameworks for Java.NET, you create a so-called parameterized test. And the test itself looks very, very similar to our unit test. Right? This is exactly what the unit test used to look like, except for this value and those values, they were hard-coded. By parameterizing a test, you put all this garbage into something, into an array or collection. So that's a parameterized test. And this is the kind of technique you would employ in dealing with this boring, tabular, data-driven kind of tests. There is a lot of boilerplate in this. There's a constructor, you need to feed the value to the test. That's been improved. I'm just going to show you a slightly more readable version of it. You can get rid of this. And this is sort of framework dependent. I'm showing you JUnit right now. But sort of the important thing is not really the syntax. It's the fact that this support is built in. And of course, a savvy developer has solved this problem even 10 years ago by sort of building a framework, building frameworks on their own for this. I know it's a solved problem, but now for a couple of years it's been built into the language. So this is what you want to do in these boring cases. So your naming problems go away, your repetition is reduced to just filling in the values here, and you can do that more exciting by reading them from files, for example, or whatever. You want something, since this is actually a big thing, that thing is possible only since JUnit, no, I'm lying, never mind. So anyway, you want to do something interesting with the way you feed the parameters to this, just saying. And this is sort of the basics of making repetitive tests less of a pain. Just to summarize, these kinds of tests really focus on data. They are not very intelligent. The purpose of a parameterized test is to sort of remove the boredom, remove the silly naming, and sort of just make these boring comparisons easier. Still, it's a basic building block we need to be aware of every time. At this point, I would sort of like to stop and zoom out a little. How many of you do test-driven development? Oh, great. So I know, maybe I'm being presumptuous, I'm not going to have a discussion here, but I'm going to challenge test-driven development a little. When I teach test-driven development, the most common question for people learning it is to say, what test should I write now? Do you recognize that? Is that sort of, does it resonate with you? What test should I write and what should I test? And it's really a hard question. And what I usually tell people is that the first test doesn't really matter. Since you don't have anything, you don't have any code to test, you don't have any behavior, you have nothing, you have your clean slate. The first test will drive out the interface for you, right? It will tell you, you usually tell people to imagine the perfect API, what would that look like? So the first test will drive out the interface, and you're obviously probably going to you're just going to fake the answer, right? That's what you do. If you do hardcore test-driven development, you're not going to do anything fancy, you're going to fake the answer. But the first test will give you the interface. Now the second and maybe third test will actually focus on the happy path. And that's sort of where you build in your, your happy path. No exceptions, no error handling, nothing can go wrong. Just sort of give you the overall structure of the problem you're about to solve. Okay, test driving so far, that's good. Next thing I usually sort of tell people is to, okay, so you've got your API, you've got your happy path, what next? Okay, so next, I usually propose to write tests that will actually teach you something about the problem. There are some dark corners where you want to shine a light, and this is the kinds of tests you would like to write. Finally, if you get that far, you're going to focus on error handling, maybe. Usually people are pressed for time and they're just going to be happy with the happy path and interface. They're going to do some kind of half-hearted thing from test-driven development. And that's perfectly okay. This is how it plays out, actually. That's just my reality. Whereas testing, if you have a testing approach, you will think differently, because test-driven development is about design. It's not about testing. Test-driven development will give you code that, with small methods, that's good with handling dependency, that's modular, that is testable, but it will actually not be tested. So if you approach this from a testing perspective, you think about different things. And as I've said, once you've got your code up and running, you need to start thinking about your data. You need to think about your equivalence partitions. In this case, I just had numeric intervals. It's simple, right? It's just numbers. But if you've got some sort of complicated object, like a big customer object, you have this legacy system, you have a customer object with 30 fields, where are the equivalence partitions? Where are the boundary values? What's important? What's not? What's not? Which values do you need to set? What do you need to test? So this is something you will normally not think about when doing test-driven development. But this is something you really need to think about if you want to write something that's testable. An even more sort of exhaustive or advanced way of doing things is actually putting everything, all your parameters up in a table, like I did in my simple premium root engine example. And you can model stuff like as state machines. It's a graphical technique. You sort of draw states and transitions. It's not really that important, but what I want to emphasize is these are basic testing techniques. They usually don't make it to the developer's mindset. And they definitely don't make it to the code, which is why, and this is the big thing, which is why a tester will start testing your software by doing this checking, like, okay, there's a text box, it accepts a number, okay, I'm gonna type -1 just to see what happens, I'm gonna type an exclamation mark. This is not the kind of work you want a tester to do. This is just stupid, immoral, repetitive work. It doesn't scale with agile development, and it's really killing your soul. And this is your work as developer to take that into account. And by thinking about these things and the tools I'm going to give you, you'll be able to do that. So that's sort of the distinction between TDD and testing. This is the talk before lunch. So on that topic, I'm going to switch gears a little and let's talk about food. I love hamburgers. Hamburgers aren't that healthy when you come to think about it. There's some piece of meat, and there's these white sugar breads that make up the majority of a McDonald's hamburger, which makes the hamburger not a very healthy kind of food. And actually I've been using a proper table from McDonald's to conclude that a hamburger contains more than 200 kilocalories. Right? Okay, still, hamburgers, in comparison to other fast food, are the least evil, at least if I get to choose the menu. So, let's look at their menu. I'm not going to give you the details here, but we have a menu, fast food menu. We've got McFish. I'm actually avoiding using McDonald's names for obvious reasons. That would be the McFeast with bacon, I suppose. There's some chicken and there's a hot dog. And I'm claiming that if I look through all these foods, and I really do miss my clicker, if I look through all these foods, the hamburger will still be the least evil in terms of calorie count. Now, what is not very good about this test? If you reviewed it, what would you point out to me?
You don't know why it fails. Which of the other ones?
Thank you. Thank you. That's a very good way of doing this. I do have a for loop, and that sort of it contributes to this. I loop through a bunch of stuff, and actually I'm breaking another rule, which is a consequence of having the for loop. I've got I don't have one assertion per test, I've got 5 assertions per test. So in conclusion, I wouldn't know when it failed. Although I do want to, I want to confirm that hamburgers are the least evil. Fortunately, there's support for that too. They're called theory tests. What makes a theory test different from a parameterized test is actually the shift in mindset. Parameterized tests are data-driven tests. You input values, you compare values with something. Theory tests open up our reasoning to what a mathematician would call for all type of reasoning. So I say that a hamburger is healthier than all my foods, all my fast foods. And I don't really care about the numbers anymore. I'm just asserting that it's healthier. So I still got my menu, and I guess you guys can see that this could play out into an infinite thing here, right? Big list. And I'm still saying, I don't care about, the timer really drains the battery. I'm just saying that whatever food I get here, my hamburger is going to be healthier. And this is a very, if you come to think about it, this is a very powerful thing to do, because suddenly you're away from actual numbers, from comparisons. You can make general statements about your tests, about your code, about the properties of your code. So this is a tool I would really like to you guys to bring with you. And again, you see, it's quite, sorry for this animation, it's quite, it's a small change really. You just tell it to run with a different runner. You just annotate something with data points and off you go. This is still the same test, but the loop is handled, or sort of the mechanics, the boilerplate of doing this is handled by the framework. And obviously the error message will be there. So you know when the test actually fails. Okay, I am getting hungry. Let's expand our thinking. And let's say that no fast food meal contains less than 500 calories. Okay, so that's true. I did pick the fast foods, and I don't have the green salad and extra carrots. That's true. But, okay, and I'm warning you, that's a lot of source code. You don't have to read all of it. What's really interesting here is In the upper half of the screen, you see just my menu. You see that I've got my burgers, I've got my French fries, small French fries, milkshakes, I've got my Coke. This is just a random pickup of fast food. The good thing is that my theory test and the framework will still support this kind of testing. And this is sort of just framework magic. I don't really have to care about, there's not much I need to care about. Just I'm helping the framework, and there are annotations to solve this. It's not really interesting at this point, but I'm helping the framework by specifying a type, specifying the types, and it will do the work for me. Now, there is one thing we need to be aware of when doing theory tests. It's the assumptions. So it's common speak, we're basically expressing a theory. My theory is that, pardon, my theory is that the total amount of calories is larger than 500 for all fast food. However, this theory does not hold if I have a Diet Coke, which contains 0 calories. So actually this test would fail, but it so happens that, and I'm not really showing you the details here, but I need to make the assumptions that I exclude diet beverages from this theory. And this is really powerful because you're going to end up, if you write these tests sort of properly and on large data sets, there will be combinations for which the theory will not hold. And doing sort of sorting them out with if statements and stuff like that, it would just kill your tests. So that's why the assume that construct is really, really important in this case. And again, just to summarize, in common speak, we're assuming that these things must hold for our theory to be true. Now, the interesting thing actually is what's happening behind the scenes. Those of you who remember your math, Cartesian products, if you've got a set, then you multiply it with another set, and another set, you get this huge combinatorial explosion. You get all the permutations. And this is what this thing actually does. So when evaluating these 3 things here, name, size, order, what this thing does behind the scenes is actually that it creates the triplets here. A hamburger, small French fries, medium Coke. Hamburger, small French fries, large Diet Coke. And so this goes on. So as you see, hamburger, first parameter, medium Coke, large Coke. Medium latte will be third, right? So medium latte, large latte. Okay, so we've covered that one. So it's gonna, the theory runner will feed all the Cartesian product of everything, all variables, all of this into that test. And the assumptions will prune away some of these. So as you see, it's giving us the opportunity to evaluate a lot of combinations. Now I haven't really actually computed how many they are, but somewhere around 5 times 4 times 5, around 100 basically, maybe triplets. And I'd say this is a very powerful thing if you want exhaustive testing, as opposed to the example-based testing, which you achieve by doing unit testing. Yes?
The previous slide there, won't the test fail because the red line coverage is high?
No, that's a very good question. An assumption just discards the test.
Okay.
It's not going to fail. It's not an assert. It's an assume. So it's just going to. Yeah, it's a very good question. So and I didn't tell the internal. So that's what assume will do. It would just sort of ignore what's happening here. Very good. Thank you. Thank you. Okay. So just to sort of make this material stand on my own, the difference between theory tests and parameterized tests is that they are focusing on general statements. There is actually no good way of actually doing comparison with exact data points. You can't say, I want this, these and these tabular values to be compared to that value. It's just sort of you let go of that. And again, for the mathematically inclined, you will see that you have the chance to try every single permutation of your inputs. As a developer, you don't need a tester to do any tables for you. You've got everything covered. It's very cheap, it's a unit test. And of course, this doesn't have to apply to unit testing at all. I mean, you can launch arbitrarily complex tests with a testing framework. I just happen to have unit tests here. Okay, one more thing. Are you familiar with the Caesar cipher? This is the classical crypto. If you take a computer like a security course, you will definitely encounter the Caesar cipher. Caesar cipher has actually been used by Julius Caesar to give orders to his troops, or so does the tale tell, at least. It's a transposition cipher. So what you do is you write the alphabet twice, and you just shift everything. You transpose everything with a couple of positions. So I don't even know how much I've transposed this, but this is the original alphabet. I've shifted it with 1 to maybe 8 positions. The transposition, the offset is 8. So if I encode Caesar, a C will be U, and A will be S. I think you get the picture. So this is SSL of year 50 BC, I would suppose. Now this is a tricky one. So this is what you do in a typical lab if you do a crypto course. And I didn't really want to do it for this presentation. So I just stole something proudly, and oh, okay, you can read it, great. Sorry for the blurriness, it's a scale image. I picked this implementation somewhere online. This would be a reasonable implementation of the Caesar cipher, I guess. And it's interesting, it's got some modulo operator, and I don't even know, and I don't even care. The main point is, does this work? The tools we have so far is parameterized tests, which will let us, we could set up many instances of stuff that we could encrypt and decrypt, right, and with expected values. We could have theory tests, but we can actually do better for problems like this. What we would like to do is actually to let go of control even more. We would like to say just, I'm just going to feed you a bunch of strings, and offset is a technical thing. It's the shift, the transposition. I'm just going to give you some transpositions, and I'm going to encode and decode, and I want the plain text. I want this to work basically. This is what you want to say. And to be sort of a bit technical, doing encoding and decoding like this is an example of an inverse function. If you apply decode, encode, you will sort of get the same result. So for this kind of problems, it's fantastic. But you don't really want to, sorry about beeping, you don't really want to carry, you don't want to put up all those data tables and stuff like that. You just want it to work. And you can actually make it work. You can write a theory test that looks like this. So you see the tests are getting even shorter by now. Even though we are expanding the domain of inputs, the tests are actually getting smaller and more verbose. So I'm saying I want a random string. I'll show you what a random string is. A maximum length of 128. Who cares really, maximum length? Here I'm saying I want different offsets for transposition. Like I don't want to transpose at all. I want to shift by 1 to 10 steps, something. So it gives me. So in this particular case, I will tell you that in this case I just get one random string. That's the way I have implemented that thing. But nothing stops me for making random string provide 1,000 random strings. I'm going to show you the implementation. So it's obviously an annotation. Right, and I need the max length, which is here, right? So I need the max length. And I only need to write this tiny little thing here. And it's actually boilerplate. I need to get the length from the annotation. I need to randomize because it's maximum length. But the important thing is actually, I want to generate a random string, and I want to feed it to my test. But in here you have basically infinite power. You can write a supplier that does pretty much whatever you like. You can make it return 1,000 strings. You can determine your distribution of characters. You can do anything here in this supplier. You can hide away all this dirt, all this logic in this supplier, and your test will still look something like this. This is called basically generative testing, because sort of here you start generating test data. Whenever you say generative testing, the word quick check will pop out. It's quite inevitable. It comes from Haskell. This is the kind of testing you would do in Haskell. It's quite old for Haskell, and this is like a standard show for Haskell, showing that we are doing this kind of stuff. And if you sort of like that, you can steal the idea from Haskell. And there is a library which does the thing I did with my code here, which is a little more high level. It actually tells, I want to generate this thing here. It's a different supplier. It generates multiple strings. And it says, okay, I want a string. It is a string. The length is between 1 and 128 characters. And the length is actually this, it even follows a certain distribution pattern. So it's quite advanced. You can really pick even a distribution pattern for numbers. And you can pick what kind of characters you like. You can really tweak this. Eventually, you will still have to provide the value from this, and it's just, once you set up a generator, just by calling next, you will get a number. And you can chain, as you see, you can chain these generators, make compound ones. Just to give you a sort of overview of what's available, I will show you some things from that API. So the thing is actually called net.java.quickcheck. It's not actually a big library. It's not a big project, and personally I don't use it that often, but it does contain some good stuff. So the generators that thing can give you is like arbitrary booleans, okay, trues and false, not really interesting. It can generate dates for you, fixed values. You might need a set of fixed values, strings. I've been showing you strings. And it can get more advanced, arrays, sorted lists. So you've got a library basically which will give you all these arbitrary generated values to feed to your tests. And then it's up to you to decide how many of them you want. And again, the generator interface is really, really simple. And this is what's called generative testing. And in generative testing, you are letting go even more. So I've been showing you stuff, you're letting go more and more, from the example to a table to theory. And now in theory, here you don't even, you still have a general statement, but you even let go of the data, which means that you might want your data randomized, or you might not. For traceability, being able to recreate your test case, maybe you don't want randomization, but basically you can feed anything. So if you write your exciting new cipher, you can do that. Okay, so now we can execute thousands of tests. Good for us. But what if we want to do the opposite? I see that my time is limited, so I will give you a short version of this section. Remember the cars, right? An actual rule engine like this would not only take gender and ages into account, it would take probably yearly mileage, safety features, brand, and driving record. Now this sort of resembles a more realistic premium rule engine. If, oh, there goes my phone. I'm gonna need help with time. I don't know, I know I have 5 minutes, but I don't know more than that. So basically, if we were to actually test this in an exhaustive way, we would need 4,500 test cases. that is more than we can feed into our parameterized test probably. We could do some kind of theory testing, but maybe this is not what we want to do, because nothing says that this rule engine is actually something that can be tested with a unit test. It might be a thing that does external integrations. It might be querying a database. So this is something that's simply not feasible to do. In this case, we need a reliable way of actually reducing the number of test cases while retaining some kind of level of confidence in our testing. So I'm going to give you sort of two words here. The first word is single mode faults. Single mode faults, it's exactly what it sounds like. If one of these variables, one of these values sort of triggers a defect, just one of them, that's a single mode fault. And surprisingly, it's really, really easy to sort of test for that. But this is something developers don't usually learn. I didn't learn it anyway. What you need to do is you take all these things, you put them into a table, you just write them out, starting with a variable which has the most sort of available values. You just write them out like this, right? And here, and your test cases magically pop out. So by only running 6 test cases, 1, 2, 3, 4, 5, 6, you're able to detect all single mode faults in this big thing. That's actually magic. Now the interesting thing is, so we went sort of from 4,500 to 6 test cases. That's quite cool. Now of course, if there are single mode faults, there's obviously going to be double mode faults. Double mode faults occur if a combination of 2 variables trigger a bug. To do that, we need to be a little clever. Before telling you how to do this, I can tell you that basically we only need 40 test cases to cover all possible double mode faults. But in this case, we're going to need some tooling support. There is a tool called All Pairs. It's written by James Buck, the big testing guru. It's actually not a difficult program. You can write it yourself. That will do it for us. I'm just going to show you how this would look like. What this would look like. Sorry. So I've input my stuff here, my gender, male, female, my age intervals, my yearly mileages. It looks like shit because it's tab separated, right? And all I need to do at this point is I'm feeding that thing into James' tool, which I could have written myself. It's a fun exercise. And actually it gives you somewhere here, it gives you the kind of table of values, the permutations you need to test to cover all double mode faults. So remember, when I had a table like this, I needed 6 test cases for single mode faults. Now I need roughly 40 to cover all double mode faults. And now the circle is closed, because those 40 values can be fed into a parameterized test. So now I've sort of come full circle. This is available in the references section. This is nothing we have time to do, but you can actually find the pairs by hand. You wouldn't want to do this in a complicated scenario. Right. And coming full circle, I just would like to summarize, especially since I don't have track of time. Unit tester examples. We are avoiding boring examples, repetitive examples by going to parameterized tests. We are introducing for all type of reasoning by using theory tests. We can then move on to generative testing, where we actually let go of the values that we are feeding into theory tests. That expands, right? We have many, many values. We contract by looking for single mode faults, by looking for double mode faults. This again reduces the number of test cases, and we can feed them into our parameterized tests or even examples. And that is pretty much it. That's what I wanted to say. I believe the time for questions is a little so and so. I can, if you're not in a hurry to do this, I can still take them or during lunch or during the remaining 1.5 days. But that's it, ladies and gentlemen.
So before everyone leaves the room, I have to give you this flyers for the lunch that you guys can have. Free. So, down here. I'll stand by the door.
Also another message from us sponsor. Ja, vad bra. Du får ju en trådlös högtalare helt enkelt. Så det är från sajt. Så den får du. Tack. Dessutom ja, ät inte bara. Det blir väldigt mycket. Tack eller? Men lösning.
Programs